Okay, we're back with test number 1, and this is a test that you actually want to do right away whenever you're trying to determine whether a series converges or diverges. Very quick one, and while it cannot tell us whether a series converges, it can absolutely tell us if a series diverges. So as I've been talking, you've probably been reading over my shoulder. It's called the nth term test, and what it basically says is if the nth term of a series is not heading towards 0, as n approaches infinity, then the series is going to have to diverge. Okay, so we're going to go back to the example from the previous video. We got the sum as n approaches starts at 0, goes to infinity, 2 to the n. Okay, so if we start punching out terms here, we know that the first term is 2 to the 0. 2 to the 0 is equal to, that's right, it's equal to 1. All right, and then now we bump n up to 1. Now we have 2 to the first, which we know to be 2. And then 2 squared, so 4, 8, 16, ... Okay, is the nth term going to be heading towards 0 as n gets closer and closer to infinity? Obviously not. It's going to continue to grow. Okay, so the nth term test helps us in this case. We know right now that this series right here is guaranteed to diverge. Okay, it diverges because the nth term test tells us that it does. Okay. Example number 2. We have the sum as n goes from 1 to infinity of 1 over n. Okay, let's start listing these terms here. If n is 1, then we have 1 over 1. All right, yeah, that's 1, obviously. If n is 2, then we have a half. If n is 3, then we have a third. If n is 4, we have a fourth. Okay, would you agree that if we were to go way down the road, we'd end up with like 1 over a million? All right, let me make my fraction bar bigger. Whoop, there we go. Plus blah, blah, blah. Yes. Okay. And would you also agree that 1 over a million or anything with a larger denominator, that's pretty close to 0? Okay, so we can call that 0. It's the series, in this case, is going towards 0 as n gets larger and larger. Okay. So, what does that mean? Well, it basically means that this test is inconclusive. Okay, we know right now that we cannot rule out divergence or convergence. Okay, if we get a case where we don't have 0, then the series will diverge. But if we get a case where we will have the nth term being close to 0, then the test is inconclusive. It does not mean this series will converge. Okay, that's what we got to be careful of. It can definitely tell us divergence. It cannot guarantee convergence. All right, so right now, 1 over n, we don't know. We don't have enough information. Okay, it might diverge, it might converge, but we don't know. Whereas with this one, we definitely know it diverges, and it's all because of whether or not you get 0. If you don't get 0, it will diverge.